Welcome back to math class today. So I'm going to go over the work that I posted last week on the Google Classroom that you had to submit and work on through Google Forms. Most of you got it done. Those of you who didn't, maybe take a break before you listen to this video if you haven't done it yet, and go take a look at it. I'm going to go over the first couple now. So we're just looking at factoring. So factoring is
Daddy,
yes, Abigail.
I want to play in the rain now.
Well, I think you should wait until later when Bubby and me can play too.
Okay, I'm going back.
Okay, love you. Okay, so let's see my breath. I maybe shouldn't be outside today. All right, so factoring is determining the values that multiply together to give a number. And we're typically going to look at these as whole numbers, as real numbers. They can be positive, they can be negative. And that's the part that can get confusing, is you have to consider you have negative factors at times. So let's take a look at example 1 from the homework. Example 1. I was looking for positive factors of 12. So to get a positive number, you would need to multiply together either two positive terms or two negative terms. In this case, I have a positive 12, and I'm looking for all the positive factors of 12. So I'm only looking for numbers that are positive. So your first thing is it's going through and seeing what in whole numbers can you multiply together to get 12. So factors of 12. Well, every number has its identity factor, 1 times itself, 1 and 12. My process is I like to work my way up through it. I like to see if that next number divides evenly into it. So next one after 1 comes 2. Is there anything, does 2 divide evenly into 12? Yeah, 2 can go into 12 6 times. What's after 2? 3. Does 3 go evenly into 12? Yeah, 3 can go into 12 4 times. And once you get to a point where there's no other numbers between the two consecutive numbers you have here, you can stop. You don't have to go and write them in the reverse order. It's not wrong, it's just unnecessary. So, these are my factors of 12. 1, 12, 2, 3, 2, 6, 3, 4, and them. I'm leaving the space to show that there are times when there's not a lot of other numbers in between those spaces. So positive factors of 12, that's what we'd be looking for. Those numbers. You can write them as pairs. You can do them like this. Suitable. Usually if you do them like this, you can connect them with lines. Example 2. We were looking for the negative factors of 12. So to get a positive number working with negative terms, both terms need to be negative. So we would be looking at the same terms. Let's start at negative 1. Negative 1 times what would give you positive 12? Well, I know it's going to need to be a negative number. Negative 12. Negative 2. Negative 6. Negative 3. Negative 4. Awesome. 1 Wonderful, great. All right, now let's look at example 3. Example 3 is where we begin to see, we can have a huge list, and this is where trials and trials and trials, continuing to practice, you'll begin to be familiar with it and be able to see what you're looking for. So we want to look for all factors, positive and negative, of a minus 12, of a negative 12. So what can I multiply together? Yeah. Well, I know a positive times a negative is a negative. So if I have a positive 1, I need to multiply it by a negative 12. Now this is a case where you can do the inverse. A negative 1 times a positive 12. These are the two options, using 1 as a factor. Then we have 2 and negative 6. Negative 2 and 6. And these don't have a specific order. You can work whichever order you want. I just like the consecutive sequential order here. All right. 3, negative 4, negative 3, 4. These would be my factors of 12. Of negative 12. All right. My next example is asking you to take a look at a quadratic, at a polynomial, and I wanted you to factor it. So, example 4. You have to remember that little symbol in my questions on the computer is the same. If I had this x arrowhead 2, that's the equivalent of saying x squared. Okay? I just can't, in Google, I cannot make it a superscript. Okay, so I gave you the relation, the function y equals x cubed plus x squared minus 2x. So we want to factor something out of this. We want to be able to break it down. Sometimes you can break quadratic polynomials into two binomials. In this case, we haven't learned this method, but what we can do is we can look for common terms within each term. So, looking here, I have an x cubed, an x squared, and an x. Every term has an x, some numbers of x. So let's break this apart a little bit. I'm going to look at the lowest number of x's. Here I have x cubed, x squared, and just x. I'm going to look at the x. I have how many x's there? I have a single x. I'm going to look at these in terms of how can I get a single x out of these? How can I factor these to get a single x? Well, y equals x cubed is the same as saying x times x squared. Would we agree x times x squared is x cubed? That would be added to x squared would be the same as saying x times x minus 2 times x. All right. Every one of those terms now I have an individual x, but they're all equivalent to what they originally were. So I can pull that individual x out and I can put it off to the side. It's like you're going to buy your friend milkshakes and you take $2 from every person. They're all going to still be the same in a sense, but you just removed a common item from each piece. And how do we represent that? We put it out in front. We use brackets, and we rewrite what is remaining. So x squared times x, I've taken an x away, I'm left with just x squared plus x minus 2. Now the question is, can I factor this equation further? Sometimes you can, sometimes you can't. Let's take a look. What are my factors? Remember the rules for factoring one of these. You have a look at the last one, you find the factors of it. Negative 2, minus 2. My factors are minus 1, comma 2, or plus 1, minus 2. Those are the ones I'm working with. I say, hey, I need to have a positive term in the middle. I need to have a larger one. So what I'm going to do. I know I can break this polynomial into binomials. I know x times x gives me x squared. This should all begin routine. I should be giving you numbers and numbers of questions just to practice. You don't have, I don't know how much you have going on. I imagine you have time to sit and do math homework for an hour, 2, 12. Okay. To get a negative 2, I have to have had a positive and a negative. And because this is a plus x, I would have a 2 there and a 1 there. This would be my factored form. Now, ultimately, you should go through and do a check. I'm going to come over here and I'm going to work through my check. Make sure you can see it. I'm going to refocus it just in case. Check. So my check is y equals x times x plus 2 times x minus 1. Alright, so you can do this in any order you want. You can multiply the x through this term first. I prefer to do the FOIL method first. FOIL method of the two binomials. I am not going to touch that x. I'm going to do this. X times x, x squared. X times minus 1, minus x. Two times x plus 2x. 2 times minus 1, minus 2. Now you want, in this case I would combine like terms. You can go through if you want and multiply that x through. It gets you the same place in the beginning. Negative x plus 2x leaves me plus x minus 2. Now I'm going to multiply that x through. X cubed plus x squared minus 2x. Now, is this what I had when I first started the equation? Yeah, it is. I did something correctly. So this checks. So my factored answer of this would be this right here. And this is something you should know. You can go back to watch earlier videos from before March break to continue to review factoring. I'm going to do the last example that we'd worked on. This was page 1. Page 2. Still the 22nd of April. Happy Earth Day, everybody. 2020. The Earth is happy probably these days. We're getting a nice clean rain. It's kind of like having an annual shower. Just kidding. Pollution's down. People are traveling less. Also, oil is below. Oil's in the negative. Last I saw, oil was negative $37 a barrel. So they would be giving you money to take the oil. They don't have anywhere to store it. It's continuing, now that they've opened these wells, the oil is continuing to come up. It's under pressure underneath. That's how it formed. And now they don't have anywhere to put it. So we're going to be faced with some sort of environmental concern, I feel, regarding that. Now, example 5. The last one I gave you was the equation y equals 12x squared plus 4x. So I'm asking you to look for a common term. Immediately I see 12 and I see 4. I know 4 goes into 12. I then see an x and I see an x squared, and I know there's an x in the x squared. So I'm going to factor out the 4. Why? Okay. How many 4s go into 12? 3. So 4 times 3 is 12. X times x is x squared. So this 4 times 3 times x, 4. times 3 times x is 12 x squared. Same as we had. Plus 4 times x. I didn't have to change anything there. So now I'm going to pull out common terms and bring them to the front. All right. There's a 4 in both terms of this expression. Anything else? Yes, there's an x. Okay. Bracket. I left a 3 and an x. What did I leave here? I left something here. Something we always just kind of ignore. Single, solitary, on its own. Everything can be multiplied by 1. I didn't take that 1 out. That 1's going to remain there. It's going to be like a placeholder to be like, hey, I'll save your spot in line while you take my kids to the bathroom. I can't factor that any further. We can go back and check it. This is just distributive properties. Distributing this 4x through. 4x times 3x, well, 4 times 3 is 12. X times x is x squared. Okay, 4x times 1. That's just 4x. Does this match what we had at the beginning? Yes. So that's a review of the assignment.